Anisotropic spatial correlation model for VS30 values for seismic hazard assessment studies. So what is the argument here? First, the earthquake IMs at regional level are especially correlated, and neglecting this could impact the accuracy of loss assessments. 2. This correlation is a function of source, path, and local site condition. 3. The assumption of isotropy may not hold universally. So, there have been several studies to create practical models to represent these correlations, and such correlations can be effectively modeled by adopting the regional site conditions in terms of VS30 values. So, developing a model for anisotropic correlation of VS30 would lead to an enhanced understanding of final spatial correlation of earthquake IMs. This is what my co-authors from International Institute of Earthquake Engineering and Seismology have worked on and developed several models. In this paper, we used this idea and developed an anisotropic VS30 model for a city for demonstration purpose. During the presentation, I will explain the procedure to develop such model and explain the differences between isotropic and anisotropic assumptions. Once it is clear why we proceeded with anisotropic assumption, I will explain this specific functional form that can produce valid covariance function, and we will see what does it mean and why it's been adopted by my co-authors. Then I will spend a good chunk of the presentation time to explain how this model can be used in practical seismic hazard and risk assessment studies. And finally, I will briefly explain about different interpolation methods that can be used to map VS30 values and how to evaluate them. So looking forward to seeing you on Monday just after the lunch in front of monitor 26. Ciao!